The phrase Fourth Industrial Revolution was first introduced by Klaus Schwab, executive chairman of the World Economic Forum, in a 2015 article published by Foreign Affairs. Mastering the Fourth Industrial Revolution was the 2016 theme of the World Economic Forum annual meeting, in Davos Closters, Switzerland. On October 10, 2016, the forum announced the opening of its Center for the Fourth Industrial Revolution in San Francisco. This was also subject and title of Schwab's 2016 book. Schwab includes in this fourth-era technologies that combine hardware, software, and biology, cyber-physical systems, and emphasizes advances in communication and connectivity. Schwab expects this era to be marked by breakthroughs in emerging technologies in fields such as robotics, artificial intelligence, nanotechnology, quantum computing, biotechnology, the Internet of Things, the Industrial Internet of Things, decentralized consensus, fifth-generation wireless technologies, 3D printing, and fully autonomous vehicles. Prior to the Fourth Industrial Revolution. The First Industrial Revolution was marked by a transition from hand production methods to machines through the use of steam power and water power. The implementation of new technologies took a long time, so the period which this refers to it is between 1760 and 1820, or 1840 in Europe and the United States. Its effects had consequences on textile manufacturing, which was first to adopt such changes, as well as iron industry, agriculture, and mining, although it also had societal effects with an ever stronger middle class. It also had an effect on British industry at the time. The Second Industrial Revolution, also known as the Technological Revolution, is the period between 1871 and 1914 that resulted from installations of extensive railroad and telegraph networks, which allowed for faster transfer of people and ideas, as well as electricity. Increasing electrification allowed for factories to develop the modern production line. It was a period of great economic growth, with an increase in productivity, which also caused a surge in unemployment since many factory workers were replaced by machines. The Third Industrial Revolution, also known as the Digital Revolution, occurred in the late 20th century, after the end of the two world wars, resulting from a slowdown of industrialization and technological advancement compared to previous periods. The global financial crisis in 1929 followed by the Great Depression affected many industrialized countries. The production of the Z1 computer, which used binary floating point numbers and Boolean logic, a decade later, was the beginning of more advanced digital developments. The next significant development in communication technologies was the supercomputer. With extensive use of computer and communication technologies in the production process, machinery began to abrogate the need for human power. German strategy. The term Industry 4.0, shortened to I 4.0 or simply I4, originated in 2011 from a project in the high-tech strategy of the German government, which promotes the computerization of manufacturing. The term Industry 4.0 was publicly introduced in the same year at the Hanover Fair. In October 2012, the Working Group on Industry 4.0 presented a set of Industry 4.0 implementation recommendations to the German federal government. The workgroup members and partners are recognized as the founding fathers and driving force behind Industry 4.0. On April 8, 2013 at the Hanover Fair, the final report of the Working Group Industry 4.0 was presented. This working group was headed by Siegfried Deas, of Robert Bosch GmbH, and Henning Kagermann, of the German Academy of Science and Engineering. As Industry 4.0 principles have been applied by companies, they have sometimes been rebranded. For example, the aerospace parts manufacturer Meggitt plc has branded its own Industry 4.0 research project M4. The discussion of how the shift to Industry 4.0, especially digitization, will affect the labor market is being discussed in Germany under the topic of Work 4.0. The characteristics given for the German government's Industry 4.0 strategy are: the strong customization of products under the conditions of highly flexible, mass production. The required automation technology is improved by the introduction of methods of self-optimization, self-configuration, self-diagnosis, cognition and intelligent support of workers and their increasingly complex work. The largest project in Industry 4.0 as of July 2013 is the German Federal Ministry of Education and Research, BMBF, Leading Edge Cluster Intelligent Technical Systems Ostwestfalen LIP, its OWL. Another major project is the BMBF Project RISCOM, as well as the Cluster of Excellence Integrative Production Technology for High-Wage Countries. In 2015, the European Commission started the International Horizon 2020 research project GRIMA, providing cloud-based rapid elastic manufacturing based on the ZIS and cloud model, as a major initiative to foster the Industry 4.0 topic. Applications. The aerospace industry has sometimes been characterized as too low volume for extensive automation. However, Industry 4.0 principles have been investigated by several aerospace companies. Technologies have been developed to improve productivity where the upfront cost of automation cannot be justified. One example of this is the aerospace parts manufacturer Meggitt plc's project, M4. The increasing use of the industrial Internet of Things is referred to as Industry 4.0 at Bosch, and generally in Germany. Applications include machines that can predict failures and trigger maintenance processes autonomously or self-organized coordination that react to unexpected changes in production. Industry 4.0 inspired Innovation 4.0, a move toward digitization for academia and research and development. In 2017, the £81 million Materials Innovation Factory, MIF, at the University of Liverpool opened as a centre for computer-aided materials science, where robotic formulation, data capture and modeling are being integrated into development practices.